So you're probably familiar with cross-site scripting. Do you know how to weaponize it to actually make it useful in the real world? Do you know how to investigate it in the SOC? That's what we're going to talk about today. So in this video, similar to what I did with my IDOR video, I'm going to use PortSwigger Academy to demonstrate how to find and how to exploit a cross-site scripting attack in like a real-world scenario. Then we're going to pivot over to Let's Defend. We're going to look at an alarm that came in the SOC triggered off of a cross-site scripting payload. We're going to determine whether that's a true positive or a false positive and go from there. So here I am inside of PortSwigger's Academy. I'm using the reflected XSS into HTML context with nothing encoded lab. Once we have this one up, I need to go ahead and find where my cross-site scripting injection point is. And once I find that, we'll do like some simple alert box stuff. That's where most people end with it. If you're in like the bug bounty space, you just need the proof of concept and you don't really have to demonstrate too much beyond that. Inside the penetration testing world, I love when I find, a cross-site scripting and social engineering is involved. A lot of people are super familiar with, well, you can scrape cookies and things like that, especially if you have like a stored XSS. But with reflected cross-site scripting, which is what we're going to demonstrate here, I like to do something like replace the page with a login page and send off phishing email off and see if I can gather credentials. You're kind of only bound by your creativity when you find a reflected XSS and pen testing, and social engineering is a component of that. So that's what I'm going to demonstrate here. We're going to actually replace this page with a fake login page and harvest some credentials using Project Discovery's interact.sh. So here I have a payload. This is in one of my GitHub repositories, one of the payloads I used inside of the OSWA from Offensive Security. And I like it, and I've leveraged it a few times. What it does is it's a image source tag cross-site scripting payload. So we're going to call up the source image of X, which is going to throw an error. Then on the error, we're going to replace the actual window in which the JavaScript is running with a remote resource. And so we can host on our own server an HTML document. You could host JavaScript. You can host whatever you want. And you're going to actually replace the entire window with that. So if you make a fake web page and use HTML to recreate like their login page or something like that, you can actually, load that, make it appear, real right in front of the victim, and they may enter their credentials. You can harvest credentials. Like I said, you could host JavaScript. There's a number of things that you could do here. What we're going to do is create a fake login page. Now there's ways that you can do this so that it will actually run within the context of the website, so you don't see anything different in terms of inside the URL. It's not pulling up your attacker IP address. You could also get a doppelganger domain and see if the user recognizes it, or you can just run it straight off an IP address and really test the end user like, hey, this page should not have loaded into a 1.1.1.1 website. That's not where I work. So that's one of the cool things that you can test with this is that you have a couple different options, but this one we're just going to go with this. It's pretty straightforward. So back inside the browser, what I'm going to do is on the IDOR vulnerability that they had a login page. And so this looks similar enough to this website. So say we're in the real world or you're in a pen test and you have a complex web app and it has an authentication portal. What you could do is you could actually get an extension called single file. What I like about single file is it legitimately will take this entire web page and put it into a single file for you. So now we have this insecure direct object reference.html web file. And as you can see, there's no difference between my local version and the live version. So what we're going to do is we're going to edit this so that the login action is no longer sending a post request here, but instead we want to send a post request to our interact.sh server so that we can gather the credentials of our victim should they fall prey to us and actually enter their credentials after clicking on the cross-site scripting payload. Okay, so we'll open this up. Once you get in here, you're going to have all sorts of stuff in here. Like I said, it is taking that web page and making it a single page, like it said. What you're interested in finding is the actual web form here. So you're going to look for the form tags. There's the open, there's the close. So what we're doing is sending a post request to /login. What we want to do is send a post request to our interact.sh server. So you can spin this up. This is totally free. If you have Burp Suite Pro, you have Collaborator there. There's canary tokens. There's a bunch of different ways to do out-of-band interactions, but app.interactsh.com is Project Discoveries, works really well. So grab yourself that. Go back over here. And just throw HTTPS on the front of it and make sure I close out double quotes. Right. And then I'm going to copy, which one? No, I have two copies in here. Is that the right one? Yes. So we're going to copy this to var www HTML, and we'll do HTML PortSwigger login. Yeah, we'll do PortSwigger.html. Okay. So now that we have that inside of our root directory for Apache, I'm going to go ahead and start Apache web server. Okay, and so we can actually go visit on our local host that site. Host, and there we go. So what we can do here is we can test, log in, and you could actually, inside of that HTML code, you could put a redirect and redirect them back to the actual website so they don't see anything like this. But for our purposes here, we won't do that. But this is just a response from interact.sh. So if we come over here, we can see that we did have DNS resolution against it, and then we actually got some HTML or HTTP requests against it. So there, request robots, there we posted to foo, and we can see username test, password test. So we are capturing credentials this way. Awesome. Oh, right. So in here, normally what you would do is host this on a publicly facing web server. We're going to call localhost. That way we can make sure that we get this. But if you had this on a public facing web server, or you even had like an FQDN, like a domain assigned to that web server, you would put that address here inside of the URL you see here. For us, we're just going to do the name and localhost. Grab that. And we're going to head back over here. Okay, so I'm sure I had to do some really weird cuts there. What ended up happening was, I guess after I solved this the first time to find the demonstration, PortSwigger Academy shut down the instance that I was working on, so I have to reopen it. So essentially, once we've found that, we've created our payload, which we have here. We're going to call the local host and PortSwigger HTML. Go back here, and we're going to do that search. And now we see we have been redirected over to the localhost PortSwigger.html. It's replaced the content of the page. Hopefully, if the victim was not aware that that should happen, they might think, well, to access this link, I must need to log in. And so that's where you're going to get, victim and password, and they're going to log in. And you're going to gather their credentials. And so you're going to end up with, victim and password. Now, inside of Burp Suite, what you're going to see there, and this would be, say you were doing a phishing campaign, you would want to come in here, and since we got redirected off of it really quickly, the victim's going to see the same thing. what you would want to do is come in here, find where you executed that payload, copy that URL, and that's what you would send inside of your phishing campaign. So it looks legit, right? This is on their, say we work here at, websecurityacademy.net, and you've sent them a link. Well, it looks totally legit. I work here, I go to this website all day long. I don't see anything wrong with this. This doesn't mean anything to me because I'm just an unsuspecting user. But in reality, what this is going to do is execute our cross-site scripting payload, redirect us off to another place, and we're going to gather credentials. So that is a weaponized example of how you can use cross-site scripting. Now what we'll do is take a look at it from the SOC perspective, where we're getting an alert that a cross-site scripting payload has gone through on a web server. We need to determine whether this was a true positive or a false positive. Okay, so here we are inside of the Let's Defend platform. I've gone ahead and grabbed SOC 166 JavaScript code detected in requested URL, and we're going to take a look at the details. So we know what the title is, we know which level. It was on web server 1002, the destination IP address, which is our victim's IP address, so our web server 1002. We have our source IP address, which is going to be important. That's probably the first thing we're going to want to look at inside of log management. So that would be like the SIM and firewall logs. We see that it was via a GET request, and similarly to what we were just looking at, inside of a search parameter, they were doing a JavaScript and using an alert payload to see if they could pop an alert box. Probably just probing to see if they could weaponize this and then use it against our victim organization here. We see that the action was allowed, meaning that the firewall did not actually stop it. That doesn't mean the attack was successful. That's what we're going to determine here. So go ahead and create a case. Continue. Going to go to log management, and we're going to take a look at source address. And this is where our attacker came from. So looking here, let's go back to our oldest log. They started out probing for, seeing if they could get an alert box to pop. They got a 302 response, so object moved, meaning that it probably was not successful. Ideally, you would want to see like a 404 or some sort of 400 error, but you could also see a 302. You get 302s a lot. Oftentimes, if you're putting in a payload that isn't working, they'll 302 you back to like a home page or back to the original search page, and it will just redirect you back. You'll just get stuck in this like endless loop of payload back to where I started, payload back to where I started. So that's probably what this is. The response size was 0, so that indicates to me that the page did not load anything of any value. I'm guessing this is probably going to end up being a false positive unless the response changes in one of these, which could certainly happen. Not every cross-site scripting payload is going to work. Same thing here. They've got a different payload, 302, and a 0 response size. Same thing. Same thing. So here they queried test, they got a 200, and they have a non-zero response size. So that does tell us that if it was valid, they'd probably get a 200 and a non-zero response size. About us, yeah, they're probably looking to target. There's the root directory. And here we are again with another payload. This is the one we saw inside the alert. And it's again a 302 with a 0 response size. So I'm going to guess that while the alarm itself is valid, there was a real reason for this to be caused. It was catching cross-site scripting payloads. The firewall allowed it. All of that is true, but the attack itself did not succeed. So I think we have our answer here. Let's go ahead and get started on the playbook. Understand why the alert was triggered. I think I just explained that pretty well. Collect data, ownership of the IP address and devices, where it's coming from, static, okay, is it web hosting, who owns the device, yeah, has us It is malicious. It was cross-site scripting. We should check to see if this was a planned test. So let's do that real quick. So back on monitoring, let's grab the source IP address. Let's go to our fake email boxes. Let's just search this. Testing. Nothing there. Let's look and see. Computer, blah, 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 plan scanning. That is not our IP address. Cool. So it doesn't look like it was a planned test. One thing we could do, go to virus total. We could look at this IP address. Malware from Fortinet. SSH brute forcing. So it's from China. Okay. So yeah, let's go back. Let's continue to finish the case or the playbook. So we know why all these things. Malicious, XSS, not planned. It was from the internet into our company network. Check whether the attack was successful. It was not. The only indicator is the malicious IP. Next, we do not need to escalate to tier 2. The attack was not successful. We were able to pretty much validate that, so there's really no follow-on investigation that needs to occur here. I don't fear that anybody's credentials or their cookies or anything like that were compromised, so we're going to say no. I'm not going to put anything here because I don't want to make you watch me write, so we just say blah, blah, blah. Confirm. We're going to finish. We're going to close this out as a false positive. So I would say valid attack, but unsuccessful. That's how I look at it. Hopefully false positive is the right answer for that. Close alert. Cool. Got a streak. Yay. Closed alerts. JavaScript. Okay. So they deem it a true positive. I always get confused on that here inside of Let's Defend. So it is a true positive because the attack itself was valid, but in terms of needing escalation, the attack was unsuccessful, so we're not going to escalate it. If that's the logic inside your SOC, that works. So you would pick true positive because, like we said, it was a valid attack. You would pick it does not need tier 2 escalation because the attack was unsuccessful. We just answered the attack was unsuccessful. The direction of the traffic was internet into our network, so internet into company. Was it a planned test? No, we saw nothing inside of our emails that indicates this was a planned test. What was the attack type? It was an XSS. And was the traffic malicious? Yes, it was, which is, I guess, why we need to do true positive here. There we go. That's our answer. So hopefully you learned something. In terms of cross-site scripting, it can be a really devastating attack, depending on how it's used. Oftentimes, like I said, you see the alert box, and that's where a lot of people stop when they're demonstrating it. But you can get some really nasty, some really cool attacks, depending on which side of the fence you're on there. So hopefully you learned something you enjoyed. Like and subscribe if you want to see more. Thanks.